You're listening to the Nightlight Radio Network. This is Dr. Zohara Hieronimus, co-host of 21st Century Radio. We are happy to present this rebroadcast of our show on Nightlight. Enjoy. Welcome back to 21st Century Radio. I'm your host, Dr. Zohara Hieronimus. The subject of human consciousness and parallel realities is, as our listeners know, one of 21st Century Radio's focus for over 2 decades of programming. So we're going to continue along that theme this evening. We see humanity has shifting language and understanding of how this dimension we experience as life is part of something even greater. We're going to look this evening at multiverses and multidimensional being. It's a topic that scientists, mathematicians, physicists, and spiritual seekers alike pursue. And our guest this hour, Dr. Stephen Manley, has taken the bold step into the multiverse with some wonderful distinctions about 10 different theories we are going to explore one by one. He is the only man I've ever interviewed who I think could actually do this for us. Dr. Stephen Manley works on experiments of high-energy accelerators around the world. He is as well professor of physics at the University of Rochester, where I suspect his students are exposed to a very deep view of possible realities and may wonder, I think, Stephen, this is fair to ask, if they can change their grades from a distance. Thanks so much for joining us this evening.
I don't know if it'll work to change the grades, but probably anything's worth a try.
They probably look. They know beforehand. Why don't you describe for us as we start what multiverse means?
Oh, wow. So that's the place to start. In fact, I had my agent was on my case to write a book about the multiverse, and I sort of thought I knew what it was. And I kept telling him, well, you know, I'm a particle physicist, so what do I really know about the multiverse? I know a little quantum mechanics, a little cosmology, but I'm no expert on the multiverse. And he kept saying, you should write a book about the multiverse. So finally, I said, okay, fine, I'll look into it. And so I spent a week or so looking into various ideas, and I realized that there was a need for a book that made a survey of all the different ideas. So then the next thing was to sit down and really decide what I thought about all these things. And doing the standard science geek thing, you know, you categorize and you make a taxonomy and you try to figure out how all these things are separated and fit together. And I realized, wow, I'm not really sure what a multiverse is. In fact, what is a universe? And that turns out to be my starting point. I asked, what is a universe? And in my mind, a little bit of a bit of a science definition. I think of our universe as anything that we can directly experience in sort of a scientific way, that we can smell, see, feel, build an instrument which can directly detect, so something where we can infer scientific evidence of its existence. So we have to be causally connected to it. So that's the basic idea. And then a multiverse would be anything that doesn't fit within that. So if there's something outside of what we can be causally connected to, then that's where I started with the definition of a multiverse.
And what I thought was really interesting is you said when you began your work, you were kind of a skeptic, thinking, you know, well, these are like dreamers who just want to dream the world into being the way they want. And you go through that actually as one of the multiverses. So if multiverse then goes beyond what our instrumentation and our rational scientific paradigm can explain, multiverse then opens up all these other realms that, for instance, 21st Century Radio has focused on with just phenomenal scientists and philosophers and thinkers and authors over the decades. They would say that it's a dominion of consciousness that goes beyond the physical body.
That some people are saying that that could be a way of thinking about this. I would actually view that more as a faith-based multiverse, not something that we have direct evidence for. If you say that the consciousness creates the reality around us, or that there's sort of a threads of reality which our consciousness can guide us through. I think that you're sort of saying the mind is independent of the chemical and quantum mechanical processes in the brain because the time scales.
It can be, yes.
When you say that, you are moving outside of the realm of what I would consider the scientific methodology that we use.
Right, so we'll come back to that then, because your faith-based multiverse is at the end of the list. Maybe for the sake of our audience's welfare and my own, because I could not explain your book without you. And many times I can explain any book I read, but yours has so many wonderful summaries of large scientific concepts that I can't adequately explain. So let's look at, for instance, your own involvement in particle physics, because it seems that numbers of people we've interviewed who have crossed the spectrum from just material science to some of the more broader concepts that you're addressing. How has your work in particle physics, for example, brought you into this examination of what a multiverse is?
Well, we've had in science in the last 30 years a convergence between our understanding of the very small quantum mechanical nature of matter and fundamental nature of forces in particle physics, and the very, very large our leading theories of cosmology, understanding the evolution of the universe in the early stages of the Big Bang, and how structure came about in the early stage of the universe through quantum fluctuations in the very earliest stages. And so it's interesting that I set out to study the nature of matter and fundamental particles, thinking that by doing this with the particle accelerators, I had control over the experiments, and then I actually made a conscious decision not to go into cosmology and astronomy, thinking that one had less to control over those experiments, and in the end, I sort of see that they've converged. So I've come a full circle and realized that in order to understand processes in the sky, so the how stars work, how galaxies form, and the evolution of the universe in the very early stages of the Big Bang, you really have to understand the nature of particles and forces at very, very high energy densities, because we live in this expanding universe. So if you extrapolate backwards, the galaxies and everything used to be in a much more compressed state, and it was much hotter and denser. So
every time somebody says we live in an expanding universe, I think of a Woody Allen film where the kid says the universe is expanding, and so why do I have to do my homework? Basically, we won't be here anymore. His mother goes, "What's the expanding universe have to do with you?"
It always reminds me of a Frank and Ernest cartoon where Frank walks in and says, "Of course I'm late to work. The universe is expanding."
Exactly. All right, so you say in the beginning of your book, that, and I mentioned that you were kind of a skeptic about all this until you wrote the book, and so you say that, and now the question is not if we live in a multiverse, the question is, do we live in multiple types of universes, and which ones?
Multiple types of multiverses.
Right, excuse me, right. Multiple types of multiverses, and which ones?
Yeah, absolutely. Well, my book covers a number of different types of multiverses, and they do range from ones that I went from being skeptical to being downright even more than skeptical about, to others where I think I started out skeptical, and as I learned more about them, I feel that they really are inferred from our best scientific knowledge right now. It's not that we can prove any of them, because by definition we can't step outside of our universe to see another universe out there. But we can infer fairly cleanly the potential existence of a multiverse from theories that we have which work very well.
And before you go too far, because I would like to take the rest of the program and actually walk through these 10, actually 11 that I see, but stages or different ways of describing. But for somebody in the audience like that character in the radio days, like what difference does it make? I mean, who cares? I have to pay my bills. I have to like cook my dinner. I have to do my laundry. I have to make my bed. I have to show up to work on time. What difference does it make?
Well, I have a couple of different answers to give to that. I think one answer is you live in an electromagnetic society. It is very likely that your job centers around that. Certainly yours does, because because we're talking on electrical devices and radio works and all of that. There was a day in the 1800s when if you had talked to someone who was learning the basic fundamental science that became our understanding of electromagnetism, you would have thought they're crazy, and you would have asked, of what earthly use is this? In fact, they would have told you, I don't know. People asked Maxwell, whose Maxwell's equations are the famous equations that really govern classical electromagnetism. They asked James Clerk Maxwell, of what use is this? And he said, well, it may be useful for circus sideshow type thing. I mean, it fundamental research is like that. At the time that you're doing it, you don't really have an application in mind. You're probing around, and then when you learn things, perhaps it becomes something that has an application to it.
Exactly.
So I think
I asked that
we need to pursue fundamental research, and you never know what will pay off and what won't.
Well, not only that, I think you've probably found as a scientist that the answer's in the question. I mean, the fact that we as humans can ask these questions, and I'm so glad you've written the book in the way that you have for a scientific skeptic, because I think it opens a door to something broader than sometimes our society gets hung up on, which is just the physical here and now that they can see, touch, feel, as you described earlier. So why don't we take a little look at first how you went about separating these categories of your horizons. I mean, you first have these space-time separated multiverses. Why don't we talk about what they share in common, and then we'll go through the 6 of them.
Okay, so first of all, I needed to create some sort of a way to categorize the different multiverses. And since we consider the universe to be all that we can experience, you then have to ask, how can something be outside of that? And there are different ways for that to happen. And so my basic categories have to do with that. So you could imagine that reality is much, much bigger than our observable universe, or the piece of the reality that we can ever causally experience. In which case, those regions of the reality are forever causally disconnected from us, and that is one sort of a multiverse. And they are so far from us. I consider those to be separated in terms of space. But physicists have a hard time talking about just space or time, because in relativity the two get mixed up. So we tend to talk about space-time. So I call those space-time separated multiverses.
Okay. So one is the beyond the horizon multiverse. I mean, I have to tell you, I was quite fascinated by all of this. I can't say that I've ever seen this all put together. Is this unique to you, or is this what's really happening out there in the field?
Well, there are lots of people who are working on this stuff. And there's one other fella, a guy named Max Tegmark at MIT, who had attempted to look at the different scientific multiverses and ideas for multiverses and create a taxonomy. And when I looked at his, I liked it very much, and in fact I included it in my book. His is sort of a theorist's taxonomy. He has categorized his universes or multiverses in terms of increasing mathematical complexity. And it's a beautiful way to look at it, but I think it's a little bit more of something that a physicist or a mathematician would appreciate. And so I tried to create what I thought of as more of a populist taxonomy, which is I don't consider myself the quickest physicist in the room. I'm usually sort of pondering things a little more slowly than a lot of my friends do. And so for me, that's an advantage because it means I'm sitting down trying to figure this out, and I just sort of start thinking about naively, which is, okay, if I have a multiverse, how are these universes separated? And so that's really where I started.
All right, so we'll start with this one. I don't know if we're really going to be able to get through all of them tonight, but we'll start with Beyond the Horizon Multiverse as the first in the space-time separated multiverses. What is it?
That one is a good one to start with because I believe that one is probably the one that is least contentious scientifically. You have to understand, if I walk into a faculty meeting in the physics department and I mention the word multiverse, you'll get a lot of snickers, and not a lot of people are going to jump on board. But I can quickly start saying aspects that are the basics that would give us the Beyond the Horizon multiverse, and most of the people in the room would agree about all of those. And so then you say, well, the Beyond the Horizon multiverse basically just follows from it, and all of a sudden the snickering will sort of stop. So what is the Beyond the Horizon multiverse? Well, that is one that comes out of our understanding of the universe as we see it today, which is we see that it is expanding, and we see that because if we look at galaxies that are outside of our little local region, we find that they're all moving away from us, and this has been known since the 1930s and is very well established. The way in which they're moving away from us is as if all of the space is expanding. So what does that really mean? It means the further the galaxy is away from us, the faster it's moving away. And the best way that I know to explain that is to say, imagine that we are a raisin in a big bunch of rising raisin dough for raisin dough bread. If we wait a moment and the dough rises a bit, then any raisin that is in the dough will move away from us. But those that are closest to us will not move away as far as those that are far away from us. So the experimental data supports very, very much the idea that we have this expanding universe. So then people looked at it and they thought, well, if the universe is expanding, if we go backwards in time, it means the universe was small and dense and hot and must have effectively exploded out of something, although the idea of an explosion isn't quite the idea that they're saying, but you could imagine that. And that's the birth of the Big Bang theory, the hot Big Bang theory of our universe.
All the way from raisin dough. I love it.
All
the Big Bang
from
theory from our kitchen. It's terrific. Maybe we'll do duck soup when we come back. Our guest, if you've just joined us, is Dr. Stephen Manley. His book, Visions of the Multiverse, Do Parallel Realities Exist? Is Our Universe One of Many? A new page 2010 release, and a link to his website and information on 21stcenturyradio.com.
Hi, this is Roberta Grimes, author of The Fun of Dying and The Fun of Staying in Touch. You can learn much more at my website, robertagrimes.com. And if you're interested in learning a lot more, my podcasts are available for free on iTunes as Seek Reality with Roberta Grimes. Meanwhile, you're listening to 21st Century Radio with the wonderful Dr. Zohara Hieronimus.
We're back and returning now to our guest. Joining us this portion of our program is Dr. Stephen Manley, M-A-N-L-Y. His book, Visions of the Multiverse, Do Parallel Realities Exist? Is Our Universe One of Many? It's a new page 2010 release. Stephen, for the sake of those of us who are not scientists, and that this can get a little heady and seem not close enough to something we can relate to, can you share with us your perspective? A lot of us have been exposed to Star Trek. We've grown up with Star Trek. Beam me up, Scotty. You know, that we can materialize and dematerialize. Teleportation is certainly something being looked at in the laboratories. Is that the kind of thing that a multiverse facilitates, if there is one?
Well, there's a relation in that the beam me up, Scotty teleportation sort of thing tends to be buried in the ideas of quantum mechanics. And there is one of the multiverses that is fairly well, how should I say it, one that is
acceptable,
well founded in the science that we have established these days in quantum mechanics. We call the many worlds multiverse.
Which is, of course, my favorite. That's your number 7. I'm going, oh, now I can relate to this one. Can I read the paragraph you have?
Sure.
And then
sure.
you can explain it. Okay, folks, this is one little paragraph on page 237, Many Worlds Multiverse, quote, in quantum mechanics, different quantum mechanical outcomes are separated in a mathematical space called Hilbert space. In the many worlds interpretation of quantum mechanics, coupled with the concept of decoherence, these different realities emerge as distinct branches of the evolving universal wave function, effectively parallel universes. Now, for the non-scientist among us, I don't know what that means.
Well, in my defense now,
I appreciate it.
That is a summary paragraph in an appendix, which was to be used for reference. Now, in order to actually explain that paragraph, you have to go back and read chapters 3 and 4 at least in the book.
And
so
understand
there's many pages that are summarized in a very terse fashion.
And I'm so glad you did that at the end for those of us that are slow learners and need recaps. All right, so what does that mean, a many worlds multiverse?
All right, so right now I was sort of halfway jumping off one cliff talking about cosmological multiverses when we took a break.
Right.
And now we're about to go off a different cliff. So I may want to come back to the other in a bit, but I'll take a stab at the quantum mechanical one.
Yeah, just to make sure we say something that the audience goes, okay, now this one I get, and then we'll go back to the others.
Okay, well, we can try. This one isn't the easiest one for that. Okay, so the idea in quantum mechanics is the distinction between particles and waves becomes very blurred. So most of us have this idea of what a particle is. You think of a BB, and most of us have an idea of what a wave is. I mean, you can imagine going to an ocean and everything. It turns out that we discovered in the late 1800s, early 1900s, that in fact particles have wave-like characteristics, and waves, such as light waves, have particle-like characteristics. So in reality, these things are blurred. And it turns out that there are big implications to that, because we had, prior to the 1930s, we had an idea of how to describe things like an atom. So we had a heavy nucleus that has positive charge, and it's orbited by an electron, which you could sort of think of as a little BB that has negative charge, and they're attracted to one another, and there's sort of this mechanical model you can use. But when we discovered that in fact these particles are waves, it meant that we had to develop a different type of set of equations to describe them, something where the wave-like properties are used. And this is what we actually describe as quantum mechanics. But quantum mechanics then comes in with a lot of strange things, because if I ask where is a particle right this instant, it makes sense, because you can look and say there's the particle. But if I ask where is a wave right at this instant, the answer has a little bit of uncertainty in it. So you go to the beach and you can point at a wave, but if I say, okay, find the exact center of that wave, well, where is that exactly? What does it mean? So it turns out the mathematics of quantum mechanics has some inherent uncertainty in it, which has led to a lot of really interesting things. So let's just think about. Let me use one example. One of the things that comes out of quantum mechanics is that we cannot predict things exactly. All we can do is give probabilities of what might happen.
And so, isn't it also true to say from the observer effect that what we observe we affect? We change it by studying it.
Yeah, so let's look at that. So let's look at an example. Let's suppose that a person walks into a hallway and they have a choice of going through 3 different doors. And all that we could calculate in a quantum mechanical sense is the probability that they might go through any one of those three doors. And that we can calculate very well. But we cannot tell you exactly which door this person would go to. Now, this is just an analogy. We don't really calculate people motion with quantum mechanics, but if we think of it in terms of particles or particles decaying or things like that.
Yeah,
so
which path would the particle take?
Yeah,
that
this
kind
of
thing.
example. But it's easier to think about people walking
Sure.
through doors. So a person walks into this room. There are three doors, and they're going to go through one of them, and all I can tell you is the probability that it'll go through. And let's just assume for simplicity that there's a third probability they'll go through each door. So even probability. They're going to pick one at random. And I can't tell you which one it is, which means if I am going to describe this in quantum mechanics, I basically, we describe the evolution of this person or this particle with something we call a wave function. That's
so these are the different realities that emerge, meaning they could go through door one or door two. Okay.
So we describe it with a wave function, but this wave function now has to contain within it all of the possibilities. And so it has to sort of include all three doors until the very instant that the person opens a door, in which case this wave function transforms instantaneously into a probability of 1 that they opened up that particular door. And so we have an interpretation of quantum mechanics called the Copenhagen interpretation, where this wave function collapses instantaneously. This instantaneous collapse is caused by the observer or by the observation of the fact this person's going through the door and knowing which door it is. And so the probability distribution is no longer smeared over all three doors, but has to be a probability of 1 of going through that one door. The problem with this interpretation is that it involves this instantaneous collapse of something that has a finite extent and size, and that's sort of faster than light information flow in a sense, and people really don't like it. It's sort of a discontinuity somehow. So there is another way of looking at it, which also works, and this was put forth in 1957 by a fellow named Hugh Everett in his PhD thesis, of all things. And he says, let us suppose that the wave function that we're going to use to describe this problem is actually much bigger. So we have sort of this mathematical function that sort of describes the whole universe, if you will. And now, instead of this wave function, this mathematical function collapsing into describing this person going through just one door, why don't we assume that all three possibilities happen? That, in fact, the person comes in and opens up each of the doors in turn, and each of them then defines a thread of reality that continues to evolve in this wave function. They don't perceive each other, but they're there. And this interpretation works.
Well, in practical terms, this would be like somebody thinking about, well, am I going to have a cake? Am I going to have a donut? Or am I going to have a cookie? And by thinking about all three, they're all three realities that are affecting something because they thought about all three. And when they just decide on the donut, still the cookie and the cake are thoughts that they might be eating in a parallel world. So maybe that's why people get fat, because they're eating in parallel reality. But I know there are people in the audience going, what are you two talking about, and who cares? I mean, the subject that we look at often on our program deals with this domain. I mean, Bill Tiller, who I just love his work, used to describe it from his vantage point in quantum mechanics that matter pulls for a fit. And we used to talk about it in terms of consciousness, that where we put our intention and our attention actually affects the way things manifest in the material world. So when you talk then, Stephen, about multiverse, is this also a portion of what you're examining? Because, I mean, it is so sophisticated. It really is.
Well, when I was writing the book, I had a friend who had just read a book called The Secret, and she told me it was based on quantum physics. And so,
I'm familiar with that.
And she wasn't the type who would be sitting down reading a quantum mechanics book. So I did have to go look at this. And when I did, I realized that there are lots of people who think about these things, and some of them do make a connection between multiverse ideas and these ideas of positive thinking affecting reality. And so I did actually include that as part of my multiverse taxonomy, and I call it a multiverse of faith, because I believe that you can believe that, but I don't think we have any scientific evidence for it. The many worlds multiverse I was describing is something that is basically a formalism that works quite well in quantum mechanics. To then say that if you have a thought, it creates a reality is a very different statement. So the problem with the idea of a thought creating reality is that quantum mechanical processes are happening all the time and going and happen very fast compared to basically the processing time in the brain, where we know about the amount of time it takes for quantum mechanical processes to happen in the brain, and we know roughly chemical and electrochemical timescales in the brain, and these things are very long time compared to all that's going on around us. So I think it's hard to draw the conclusion that we have that quantum mechanics as we know it governs our reality. That said, I believe that people argue that conscious thought is independent of the electrochemical aspects of the brain. The minute you say that, you're taking a step outside of scientific methodology that we know about. I mean, what forces are you talking about? How could it possibly, what is it that works? I don't believe we know everything about the universe. And as a scientist, I'd be very excited whenever we discover new things. So I'm not saying that we'll never understand such a thing, but in our current understanding, I don't see how consciousness can be independent of the electrochemical reality, which is our brain.
And yet, of course, as you even point out in your faith-based multiverses, I mean, humans and in all spectrums of our society have always had concept, if not abilities to describe states of being that are not physical and that are replicable by people in various states, whether it's alpha, beta, theta, etc. And maybe when we come back, we can take a look at some of the bigger pictures you're looking at, because you're obviously looking for the science of multiverse, whereas I'm much more involved in the experience of whatever this multidimensionality is. And maybe we can talk about that, the difference between what humans can describe in experience versus do we have the science to explain it. I guess, would that be a fair way to say that's what we're sort of looking at?
That's part of the point of the book, was to sort of lay out some of these different ideas and to distinguish those that are inferred from science that we know it and those which people believe in, but they're not inferred directly from the science that we have.
Mm-hmm. It's a most unusual book, and truthfully, there are very few books I read that I think that I need the author to explain it to me. You have so many far-looking, let's put that way, outside the box, but from a mainframe of science, it's extremely unusual. So I thank you for taking the time to be with us. This is 21st Century Radio, and I'm Dr. Zohara Hieronimus. We'll be back after this.
Hello, my name is Judy Tallwing. I'm an Apache elder and a medicine woman, and I do medicine paintings. I'd like to encourage everybody to please go to the American Visionary Art Museum out on Key Highway, because it's a great light in the city of Baltimore. And you're listening to another great light in Baltimore, 21st Century Radio with Dr. Zohara Hieronimus. Thank you.
We are back on 21st Century Radio. I'm your host, Zoe Hieronimus. We return now to our guest. So, Stephen, You are just a wonderful gentleman, and you are very patient. I don't know how I would do as a student in your class because I'd be asking too many questions. But if you were to tell me as an interviewer, what are the big questions you're asking? Because I can tell you, folks, we have now touched on 2 of the 11. You've not heard about the fecund multiverse, the oscillating Big Bang multiverse, the ekpyrotic multiverse, the cyclic patch multiverse, the mubble multiverse, the mathematical multiverse, the concepts are enormous. So what are the big questions you're asking?
Well, to me, I was wondering a little bit what the hype was about, and so I think, to me, the real excitement is that we have many different ideas. I mean, some of the ideas are not new at all. People have believed in heaven or hell for a long time, different planes of existence, this type of thing. That's not really so new, and it's probably new to call it a potential multiverse, and that maybe is a step off a cliff that I took just because of the way I defined universe. I found those ideas actually fit the multiverse definition. What to me is really exciting is that many of the ideas that I talk about in the multiverse are actually, in the book, are actually inferred from leading scientific theories, legitimate scientific theories that we have out there. Quantum mechanics works. It is well supported scientifically. One interpretation of quantum mechanics is this many worlds idea, and it's a reasonable interpretation. The implication is amazing. It doesn't mean that we can step outside of our thread of reality in the great wave function and see these other multiverse and these other universe or these other threads. By construction, you really can't do that. But it is a legitimate idea. In cosmology, in our different theories of the evolution and origin of the universe, there are many of them where a multiple universe reality basically just follows. And it's very exciting because cosmology has gone from a science that was sort of on the scale of different types of science. It was sort of guesswork to one which now they do fairly precision measurements, and they are trying to distinguish between detailed models of different sorts. And within these, the favored model is one. We call it the inflationary hot Big Bang model, and in this model,
and you're not speaking about. You're not speaking about. When I read that, I'm going, yeah, it sounds like Congress to me. The inflationary cycle. What is it called again?
The inflationary hot Big Bang model.
There you go. That's our Congress.
Yeah. It works pretty well. So I mean, Big Bang basically meaning we know we live in this expanding universe, so we go back in time. But if you do that, things get very hot, so we call it the hot Big Bang, and we can derive a lot of. We know a lot about things at high energies and high energy densities, so we can infer what the world would have been like at that time, or the universe at that time. And we can then go and look for evidence that existed, and we see very good evidence for it, one of which is called the cosmic microwave background, which is basically light that comes to us from all directions, and in the hot Big Bang model, we expect to see it. And I think maybe it's not worth our time for me to tell you where it comes from and why we believe in it, but it's a solid prediction of the model, and it's seen experimentally. So this stuff really is fairly well supported. Inflation is an idea that the universe started out very, very small and then expanded enormously fast, much faster than the speed of light, and created a reality that's vastly larger than our observable universe. And it may sound like a wacky idea, but it turns out to fit in very nicely with the Big Bang. It sort of fixes some of the problems in the Big Bang, and it is actually, strangely enough, something that is potentially plausible given quantum field theory, the theories that we have in particle physics that work very well. So this is sort of the paradigm. This is the leading thing. It's called the inflationary hot Big Bang model. But within this model, the reality that we are in is vastly larger than our observable universe. So it turns out that a couple of these multiverse ideas basically just follow from that. And that, to me, is very exciting, that some of these ideas really are inferred from science.
Well, so obviously, I mean, I think one of the things 21st Century Radio and my own programming over the years in other ways has focused on is the place where science and spirit meet. And that is often why I have over the years interviewed in particular quantum physicists, because I felt they were the closest with a particular kind of reverence about life and the mystery of life. You know, sometimes clinical, mathematical kinds of scientists can be a little dry in terms of
surely not.
and trying to find how these things matter to a person not engaged in it, who doesn't sit around and think in formulas and doesn't really care about a black hole. They want to know where their missing socks are. And so how, though, I mean, for you, you must be just a wonderful educator. You have such a beautiful way of taking very complicated things and making them more manageable. For a person in the listening audience who goes, well, I can tell you that I can see the future, and I can tell you that I have dreams of the past. What does a multiverse have to do with that kind of sensibility?
Wow. So people have these experiences that you're talking about. In a number of the interviews that I've had, people like talking about UFOs and things where they've had experiences that they're trying to fit into the whole multiverse idea. And I don't have a good answer for any of that. I mean, when it comes to UFOs, if one lands outside in the quad outside my office right now, my reaction is, one, probably scared and I run, but truthfully, I would look at it and I would be very excited, because I would want to know what they know that we don't, that I can learn about. You know, that would really excite me. But I wouldn't really think that they're flitting in from some other dimension. I would think that it would be a simpler explanation to believe that they probably figured out a way to travel vast distances and are coming from our universe, where it is vast enough that I believe there is life out there. So some of these experiences that people have, I mean, I don't know what to make of those. And I do sort of categorize, I make some categories in the book, basically the faith-based arena, where you can believe in different planes of existence, but they're not causally connected to us, because then they would sort of enter the realm of more our scientific thinking rather than these spiritual planes that people tend to talk about.
Yeah, I don't know that I'd agree with you on that particular subject matter, because we've interviewed so many astronauts and scientists who have worked with hard fact material that has come from space sites and crash sites. But that's for, a discussion on another evening, because we're almost at the end of the evening. I want to be sure to end in an arena where what you're looking at is something that science is articulating. Because why? Because we're moving into the space voyaging realm of our evolution, and it's important for us to understand?
I think that science has evolved as our understanding of the universe has evolved and as our instrumentation has evolved.
Mm-hmm.
And I think that we talked a while ago about why is this important to people, and why do we care? And I think that it is unlikely that this will yield a better toaster, at least not anytime soon. And I think it is unlikely that we're going to have a transporter based on a multi-universe reality anytime really soon. But we have always had great advances in our scientific understanding of the universe when we have managed to move away from the human bias.
Mm-hmm.
So, for example, the Copernican revolution, where we basically moved from an Earth-centered universe to a sun-centered universe. And then we find that the sun isn't the center of the universe, but it is in a galaxy. And our galaxy isn't the center of the universe, but it's one of many. And now perhaps we are in the ultimate of the Copernican revolution, in that we are finding perhaps our universe isn't even unique.
There you go. I love that ending right there with the multiverse. Our guest, Dr. Stephen Manley. Thank you for being with us, Stephen. Visions of the Multiverse. You can find all our guests online at www.21st21stcenturyradio.com.